Today we start the polymer composites. Composites are engineered materials comprising of metals, ceramics, glasses and polymers. Polymer composites is the material which is made up of polymer matrix and reinforcing materials being put together with defined interface. The boundaries between the matrix and reinforcement is called as interface. Next point is the constituents of composites. Polymer matrix space. It is gives continuous body constituent surrounding the order phases and gives a bulk form to the composite. Commercial thermoplastic and thermosetting used as a polymer matrix. For example, epoxy resin, polyamides, etc. Next, reinforcement or dispersed phase. They are structural constant like fibers, sheets, particles which are embedded in matrix phase. It provides high strength, rigidity and enhanced matrix properties. Functions of matrix phase. It binds the dispersed phase together. It helps in distributing externally applied load to the reinforcement. It prevents the development of cracks due to its plasticity and softness. It protects the dispersed phase from the chemical action. Important dispersed phase constituents. Fiber. Glass fiber. The glass fiber are produced by passing a glass melt through the small orifices or holes and cooled. Glass fiber are popular reinforcing materials. Carbon fiber. They are prepared from the carbon by oxidation under the tension at a low temperature and they carbonize at 100 degrees Celsius. These fibers are stiff, strong, even high temperature. Aramide fiber. Aramide fiber is the aromatic polyamide. Example: Nomex, Kevlar. It has liquid crystal polymer property. The fiber have very high tensile strength, impact resistance, high thermal stability. Silicon carbide fiber, aluminum oxide fiber, metal wires. Next point is the particles. See the particles: metal powders, metal oxides, carbon black, metal carbide, silica powder, mica, salt can be immediately mixed with the polymer matrix to make the composite. These materials offer high abrasion resistance, high mechanical strength, better performance at high temperature to composite and may modify thermal and electrical conductivity of the polymer. Next, classification of composites. Particle reinforced composites, fiber reinforced composites, structural composites. Particle reinforced composites. The particles are evenly dispersed in all directions. The strength of the bonding at matrix particle interface detect the mechanical property of the composites. Next, fiber reinforced composites. The dispersed phase in the composites is the form of fiber. The fibers provide very high strength. The fibers are either continuous or aligned. Structural composites. The structural composites are two types: laminar, sandwich. Laminar composites consist of sheet or panel tacked with a proper orientation and cemented together with resin, for example, plywood, Polywood. A sandwich, two stronger outer sheets separated by the layer of material called as core. See the glass reinforced composites. See the properties: low coefficient of expansion, low density, that is a 2.5 gram per cc, low cost of production, high dimensional stability, high tensile strength, high heat stability, better abrasion, better toughness. See the next point is the applications of glass reinforced composites used for automobile bodies, chassis part, racing vehicle components. Next, used for boats body, proper lift shafts, parts of aircraft, sport goods, musical instruments, toys. Next, used for high speed machinery part. Next, used for PCB equipment parts, bodies of refrigerator, coolers, cabins for office, windows, doors, etc. These are the applications of the glass reinforced composite.